Hi everyone, welcome back to SAT Math Question of the Day. Here we have our question of the day. Please try it. Pause the video, come back, and we'll do it. Okay, f of t is equal to that thing. Looks like an exponential function. Which of the following is an equivalent form of the function f in which the base of the exponent is 2? Oh, wow. So we have to use exponent rules. 4 is equal to 2 squared. So now we just substitute that in to get 80 times 2 squared up to the tth power. So that's 80 times 2 to the 2t, because a to the b power, a to the raised to the b power raised to the c power is a up to the b times c power. So let's see if
that's because.
So I guess that's the answer.
That's because we should know why. We should recall why.
Of course, of course.
That's because. Let's do that. That's because what? A to the b. When c is a counting number, this is equal to a to the b times a to the b.
C times, right.
Written out a to the b, c times.
Right. That's right.
Right? And so there are a whole bunch of a's multiplied together. How many of them? There's b from here, and there are c of them.
Yeah.
You have a whole bunch of b's, a whole bunch of a's, b here, there are b of them here, b of them here. In total, the total number of a's multiplied together is b times c.
Right. Okay. Yeah, we got it. Okay.
So.
It's also nice to use an example. Let's say x cubed.
Well, let's do an example. Let's do the example. A is equal to 2.
No, but there are too many 2's. Let's use
and b is equal. Well, in this example, a is equal to 2 and b is equal to 2.
I know, so it's confusing.
But it's not as good an example as if a and b were different.
I know.
This is the example that is used in this SAT question.
I know, but right now
No, I'm not. I know you know, but I'm saying this for our audience.
No. Yes. So you just went on an exposition about this. So let's apply this to an example where the numbers aren't the same. So if you have x to the third to the 5th power, that means that you have x to the third times 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 x to the third. Now, when you multiply common bases with exponents, you add the exponents. So this is 3 plus 3 plus 3 plus 3 plus 3. This is 3 times 5. This is 15. Okay? So you see how it's sort of...
I wrote out 15 x's next to each other multiplied.
Right. Okay, so that's how that works. Now, this also uses a big principle called substitution. In algebra, substitution comes up like all over the place. We have to substitute. The 4 is equivalent to 2 squared. So we substituted or replaced this 4 with 2 squared. And then we applied the exponent rules to get the answer. So the exponent rules work. They're great. They're really important to know them, and to know how to apply them and know when to apply them. And that's what they mean by a common base, by the way. But yet again, all the answers have a common base of 2, see?
Yeah.
All the answers have but that's what they mean by a common base. The base of the exponent is the thing you raise the exponent to, but Seth can explain that better. What's the official mathematical explanation for the base of a exponential expression?
Oh, well, the general exponential function is a function of 2 numbers.
Yeah.
and the numbers do not have equal status. It's not a commutative, two number function. One number is called the base, and the other is called the exponent.
Oh, I see. So the official name is base. You can't get
Yeah,
around it. Right.
With the
So
function in
y
general,
is equal to
it's
b to the x.
a to is what you want to write, a to the b, b to
Well,
the x.
yeah, let's
When you have the
throw a
function
coefficient in there.
a b to the x,
No.
b is called the base, and the x is called the exponent.
Right, and then you have a coefficient in front called a.
Yeah,
but
and
nobody...
then there's a coefficient. Yeah. Now, the official mathematical thing is exponentiation in calculus. The exponential function in calculus is introduced first with the natural exponential function, in which the base is e. So in calculus, they start with e to the x.
Yeah.
And then they define b to the x as e to the natural logarithm of b multiplied by x.
Oh, okay. Well, that's a little bit above.
So they first define e one, and then they take the inverse function of e. When y is equal to e to the x, then the natural log is defined so that the natural log of y equals x. And then they define the logarithm. And then by use of logarithms and multiplication, they define general exponentiation.
Okay.
Now, how is e to the x defined? There's several approaches to that. Several approaches for defining e to the x.
Okay. I think we're above everyone's level.
But this is calculus.
Right, exactly. So I think I would love to actually talk to you about this on another video.
The cool thing about the SAT is that it's a gateway to going to college, where you could learn the really cool subject called calculus.
Right. Okay, so that's a good motivation to do as best you can and to go into STEM, whatever STEM is, science, technology, engineering, and math. Yeah. Okay, so today, wait, we have to check the answer, don't we? So, this is very interesting, and I would love to talk to Seth and maybe in another video about this. I'm sort of familiar with this whole thing, but I'd like to learn more about it, but not now. Okay. Clear all drawings. Let us see. I think this was the answer. Yes. Okay, let's see how they did it. Probably not a lot of steps. That's right. Only 3 steps. We need to apply the following exponents to rewrite the exponential function. Since 4 is 2 squared, we can substitute the 4 for 2 squared. They don't show the exponent rule. They just say it. We can write 2.
They do.
That's too bad. Oh, they do say the exponent rule. Oh, you're right. Sorry. Not reading. You're right. They do say the exponent rule. They apply the exponent rule, and then they get the answer. Okay. So, today is Throwback Thursday.
Rewriting is substitution. It's using substitution.
Right. Very, very important.
Use or do.
Yeah. It's when you do algebra, I would it's really helpful to make a conscious effort to notice how many times you substitute. And then you will see that you will be substituting in almost every problem. Okay, so today is Throwback Thursday, where we go back to a test from years ago. This book is from 1986. It is now in 2023. We're almost 40 years ago. We have a question from 40 years ago when the test had a whole different nature. So they were more tests of more like IQ and intelligence tests rather than just tests you learned and stuff you learned in school. And around 2016, they moved to test take things you learn in school. Anyway, let's go here. Oh, here we are. Here we are. Here's our question, throwback
Oh,
question of the day. Ouch! You will
oh, wow.
not likely to see this question. Not even we've been doing 19, we've been doing early 2000 questions. This question wasn't even on an early 2000 question. Okay. The container above has a rectangular base with sides that are perpendicular to the base. If a cut is made along each of the four vertical edges, okay, got it. Use a knife, sort of, and the sides folded out, which of the following patterns results? This is called a net, I think. Not
It's called a what?
a net. We never learned
A
about
net?
nets. We
A
never.
net.
Have you ever learned nets? I never
I've
learned.
never, I've never, uh, I never heard the term net
Yeah.
for this thing.
Oh yeah. Yeah.
I've never heard of it before.
When we went to
Uh,
school, nets were never taught. Now nets are sometimes taught.
they are.
Yeah. Yeah. Yeah.
Well, this is the kind. This is what would they call? Uh, uh,
I
yeah.
think it's this one.
There's a developing. No, I'm trying to. No, I don't remember other words
Oh
I've used,
God.
but I can't say that.
Maybe.
Well, what I would say about this is that that this is the type of problem that is used on some forms of intelligence tests.
Yeah.
It's a problem that can be solved by visualization,
Right.
spatial visualization, and people vary in their in how well they can do spatial visualization.
Maybe that's why they
That's
got rid
one.
of it.
There's one method. So one approach to it is to visualize it in your mind, and that works better for some people than for other people.
Maybe this is why they killed.
Another approach, maybe Joel, you could figure out an approach that's based upon mathematical analysis of the figure.
All I'm saying is maybe they took this question out because it really discriminates against people who have spatial issues. Um, but yeah, the way I did it is I looked at the pattern. I noticed that look, this is a little thing, right? This is a little thing, and this is a big thing, right? It's higher than it is. It's higher here, right? So these two little tabs can't be the same size, right? So you got to throw those out because one little tab is smaller than the other. So that means it's either B or D. I'm not sure about E. I mean E, no, E they're the same size, so you got to throw E out. So I'm just hacking at it. Now, I said either it's B or D. But then I said, wait a second, they look similar, but the small side, this small side touches the see the smaller see this thing this if you flip this down, it goes like God, God, it what does
Yeah,
it
yeah,
do?
yeah.
If you flip this down, it goes like that, right? Yeah, I think. Yeah. So no, all I'm saying is that this little height thing is consistent with this. What's going on here?
Okay.
See that little thing there? That's
Yeah,
consistent with this. And the bigger thing is consistent with the higher thing here. So this makes the most sense. So I would say it's this one.
yeah. Okay. So let me try to sketch a mathematical analysis.
Everyone's going to
Number
do this
one.
problem a different way.
Number one.
Everybody's going to do this problem a different way because everybody thinks differently.
Yeah. It's a non-spatial way.
Ooh, a non-special way.
First, they say it has a rectangular base.
Right.
The base is invisible. It's under there.
Yeah.
So let me draw the base first.
And I will help
Here's the
Seth by clearing
here's the
some of my
rectangular
junk out.
base. Now, let's think that this edge of the base, let's call it AB, corresponds to these two corners that we see, and call this one A and this one B. Therefore, when we continue around the base in a counterclockwise direction, the third corner is C, and the fourth corner is hidden.
Right.
Right. Now let's see what the shape that is on the other side of AB. The shape that's on the other side of AB is a trapezoid. Let's label its vertices. There's A and B going counterclockwise. Let's call this D and E.
Yep.
Okay, and so AE, and then when it's folded out, AE is going to be perpendicular to AC. Oh, sorry, it's going to be perpendicular to AB at A. And so E is here.
Yep.
And the shorter side of the trapezoid is D, and that's here, and then there's a straight line on this side. Now, similarly, going the other way, here's F, and here's G. So F would be here, and G would be here. Okay?
Right.
So what we have is what we've identified is this big trapezoid that's common to three of the figures. So it's one of these. And then what Joel did was look at the tabs. So let's see what the tabs look like. The bottom tab also its corner in the short tab faces is also labeled D, and the other side of it is G.
Oh, that's
and
G.
Then the longer tab is the one that has F and E. So we actually do have to. What Joel did was realize that the tab, what do you call it? CG DB is the shorter rectangle, and it's adjacent to the shorter end of the trapezoidal sides.
Right.
So what I did was replay what Joel said, except that I put names onto the vertices so that I could talk about them rather than talking about them by pointing and saying left and right and here and there.
Right, but the way
if you were reading this argument, or if you wanted to write it in a rigorous mathematical form, what mathematicians do is give names to the elements of the structure instead of talking about this one and that one.
Yeah, okay, but now we're getting to the issue of there's a difference between doing a problem methodically and rigorously and getting it done in 3 minutes and getting it done in 20 seconds.
No, the thing is, doing it in 3 minutes.
No, 20 seconds.
Well, depends on your ability to do it non-verbally,
Yeah.
but by means of spatial realization.
Right. Yeah. Yeah.
And so the thing is, what would be if what would the approach that's taught in math classes is you we never had this kind of question taught to us in a math class.
That's right. That's right. And that's right. And that's probably
Yeah,
why
what
the
we did
SAT stopped
do, at
training
least
on.
what I did, is I had many semesters of mechanical drawing courses
Yeah,
and
well,
problems like
people
this.
in 1986, they didn't have in high school in 11th, 10th, and 11th grade, they didn't have many courses in mechanical. You had to use some IQ intelligence here. And good luck to that. Back, we took the test in the 70s and maybe Seth in the late 60s.
Yeah,
Good luck for us studying for a question like this, right? There was no Khan Academy. I mean, they could
yeah.
have asked anything.
I went to Brooklyn Tech,
Yeah.
and I had about 10 semesters of technical
Right.
drawing
So you would have had no
in
problem
the
with
four
this.
years of high
But
school.
almost nobody went to that school. So this question is anyway, now in eighth grade, ninth grade, they often talk about nets. And there are like still 12 ways to have a net for a cube. I mean,
Oh,
when we're done, we can do a search. I'll show you, Seth. We'll do it on the internet
okay.
here. But this
Yeah,
whole big thing about nets.
yeah,
Anyway, let's see what the answer is. Do we
yeah.
concur that it's D, Seth? Do you concur?
Yeah.
So
No, oh wait, D.
yeah. Do you think that's the answer?
Yeah.
Okay, let me look up the. Oh my goodness! Whoa, some of these questions are really funky. Section 2, question 3. Wow, they put it in the very beginning of the test.
Yeah.
It is D. Yes, it is D. Now, back then they never gave explanations; they just gave the answers. Okay.
Yeah.
So this is really a question about nets. So I guess let's say goodbye to everyone. Then we'll look at nets on the internet. Because Seth never heard of a net. Can you believe it? Can you believe it? Yeah, I believe it. Anyway, Seth, PhD I'm mechanical engineer. I'll introduce myself first. I'm Joel. I'm
Well, let me
PhD
say
mechanical engineer.
in computer graphics,
Yeah.
a word for this, well, a word for a related idea. The word for how the surface of a three-dimensional object is composed of two-dimensional faces is called a mesh.
Okay. Wow.
But a mesh is not, they do not consider the mesh to be, they do not show the mesh to be unfolded, so
Okay, Seth,
the word
Seth, we'll
mesh.
talk about the mesh after we say goodbye to everyone, okay?
Yeah, okay.
Okay, we got to say goodbye to everyone. Well, people, I'm sure
Goodbye,
98% of our audience has already left, which is
Yeah.
fine. So I'm Joel. I have to introduce myself first for a change. I'm Joel. I have a PhD in mechanical engineering, and I take them one very practical. Just get it done. We got to answer this question in 10 seconds or less. Seth is a PhD in math from MIT. He's a professor emeritus of computer science at SUNY Albany. We are here, hopefully, to show you different approaches on how to actually do the SAT math questions. Also, maybe show you how to do it if it wasn't an SAT math question, but basically give you different approaches on how to do these questions. And the approach we suggest is going to Khan Academy, doing one of their courses. They give you 600 or 700 math questions to practice on. They're sanctioned by the Math SAT people. And after you practice on those questions, go to actual Math SAT questions and practice on those. Okay, please dislike, please give us comments on our videos, and if you have any SAT math questions you want us to go over, please email them to us at satmathquestionoftheday@gmail.com. And if you hold on, we will talk quickly about nets, and we will introduce something that is very useful, which is GeoGebra. GeoGebra, or something like that, right? GeoGebra. And no, what we do is we do GeoGebra It's hard to spell. GeoGebra nets. Okay, GeoGebra nets. So, GeoGebra nets. Nets of 3D shapes. Fine. So, let's do net of a cube. Okay, net of a cube. Here we go. Look at this. That's a net. Come on. Come on, computer. So, this is a cube that's been... Oh, there's a way to fold it. That's just what a cube looks like if you just smash it. Now, where's the way to... Oh, look at that. So these are the different ways you can flatten a cube, basically a box. I wish there was a way to like... There's usually a way in GeoGebra to make it look... Make it... Oh, here it is. Here it is. Open the net. Ready? Ready, everyone? Isn't this cool? There you have a box.
Oh.
There you open it up.
Yeah.
That's the net. See, you take a box, you cut it all up, and you flatten it up. Right? But there are different ways to do it. There's this way. See, this is also a cube. See that? So this is nets. How about this one? 8? Oh, look at that. That's another one. What is? I think there are like 12 different ways to do a net I don't know. Never really... As you can see, I'm not a net person. But, so you never saw this before? You never heard of the word nets of a cube?
I had not. I'm looking it up on Wikipedia, and I see it is a conventional word that's used.
Yeah. Oh yeah. Oh yeah. Oh yeah.
Yeah.
Look at that.
Huh.
Yeah. Anyway, so this GeoGebra is a great website. You want to play with something in geometry, you just type whatever you want to do, like trapezoid or cross sections of a cone or nets or just whatever you want to do, parallel lines. You just type GeoGebra with parallel lines in a search engine, and you get great stuff. You can see this person, Anthony Orr, made this little project. So I guess that's it for today, right? Okay,
yeah.
So that's it. You learn a new thing every day. Yeah, nets were not taught back in the late 60s, mid 70s. Okay, everyone, have a great day. Bye-bye.